Hello, it's Rizwan here. Today is the 20th of June 2024. Today I'm just going to demonstrate my one-day time box of my R&D project using running a RAG model using the Ollama3 Facebook Meta's language model. All of this is run completely offline. So basically, first things first, go through the data here. So it just goes through the directory of data that I have. So it's just a bunch of freely available, just some like Navy things you can find online, Navy manuals. And then we go just in total around here. It's around like 172 megabytes of data. So quite a lot of textual data in my opinion. Now we'll go through just the first part, which is just like looking through one of the manuals here. So we see one of the limitations when you have a LLM to pass through some textual data and the textual data is structured in a table. If you highlight like this, you can see that it's not going to do really well. It's not going to really know how it's formatted. So that's just one of the limitations when going through these type of unstructured data. Um, so in here, just we have a bunch of graphs and just some numbers and dot points. So its job here is just go through of it and try to understand the text. Um, yep. So that's just the data that I have. In terms of the model, I used the LangChain. Um, so LangChain, and then I used the chunk of just 800 and chunk envelope 80. So one of the problems with LangChain is it doesn't really have nice functions at the moment where you can kind of do what Llama Index does, which is semantic chunking. So semantic chunking, it can give a better process of storing information. So you can imagine here this is a RAG model pipeline. So the first thing to do is you chunk the text, but if you chunk it based on like a certain number, but not chunking it based on the semantic meaning of the actual document, that's gonna affect its accuracy rate. So imagine you just chunk it based on like one page here and then next one page, but semantic chunking you chunk it based on meaning. So like this here, maybe it's the same format on the flight preparation. It doesn't stop until like let's say over here because it's different context now. So that's one of the main limitations with using these kind of splitting documents based on a number size. So um, that's just what I think. So maybe in the future can look into it, but at the moment just with one day time box I didn't look too much into it. So in terms of the language model, the embeddings and the model itself, it's the Llama 3. So when you run Llama 3, you have to do your own server that you have here, which is the um, using the little software that Facebook provides. So that's just something I did here. I'm not going to go through all the code because I didn't structure that well. So this is just the main important things. So I didn't fine tune it that much. So there is some accuracy, which I'll discuss later. So in terms of the embeddings, so the embeddings is what takes the longest. So it's the top part here. So actual chunking and storing the embeddings into our vector database, which I used ChromaDB. So in total, it took 2 hours and 32 minutes. So I think that there is an improvement that can be made, but at the same time, when looking through the logs, engaged my gaming graphics card here, and it you can see it actually engaged layers of the GPU and it goes through the embedding. So maybe in the future there's some fine tuning that can be done during the storing embeddings as well. So maybe like some type of different embedding model, or maybe using a cloud service like AWS or Azure that can help as well. So these are just something that I did here. So next I'll go through just the query and just look at the accuracy of its responses. Hello, it's Rizwan here. Now I'll demonstrate the output of the language model. Again, just a reminder, I did not fine tune this and the prompt template is not that good. So there's not much fine tuning. This just demonstrate the speed of the language model in the RAG pipeline. So we'll go through the manual here. This is just a manual provided about a gas turbine. So namely, what else found interesting was the fire alarm. So maybe like we'll ask it something like the CO2 discharge nozzle. So why did the CO2 discharge nozzle release in the LM2500 gas turbine of the Navy vessel? Navy vessel. and I want it to answer me in a way that's kind of towards an engineer. So the language model is acting as an engineer. So I wanted to answer that for me. This took 2 seconds. Again, I'm recording this, so that might affect the speed of the responses as well. And we'll see what it outputs. So go through here. So the many reasons why a CO2 nozzle might release. Maybe there's a fire, or maybe someone didn't repair something. So yeah, it should be outputting. Okay, so it's answering quite weird. So based on prior context, we can rule out issues related to high speed compressor. Indicate significant problems, gas compressor or turbine in a 200. Okay. Thermal or mechanical issue within the engine's accelerator gearbox or scavenge system. Maybe thermal overload, something like that. Like fire, so thermal fire. And a cooling, lubrication, stress, malfunction. That could happen. Mechanical stress. Maybe some oil leaked into it or something. Pressure flow issues. To confirm this suspicion, I would recommend if against the following: verify condition functionality of the gearbox and scavenge system components. I'm not sure what that is. Okay. Pressure. Yeah. Anyways, so we'll go through what the important part is that it references the sources. So this is the pocket guideline. So it's quite good that it references all this based on the pocket guide, and it took around 2 seconds, and to structure this maybe took around 41 seconds. Again, this can be improved based on the device you have, and if you're using cloud as well, it can be better. So this is just something. So this can be definitely improved. In my opinion, I think we can structure it better. Thank you.